Hello everyone. In today's session, we'll see plotting graphs in Python using the packages of Matplot library. I'll share the screen where I'll be running certain code snippets to illustrate the usage of the Matplot library. Okay. To use the Matplot library, we'll import the package from Matplot library, and we'll be importing PyPlot package from the Matplot library. So from Matplot library, I'll be importing only PyPlot. I'm not importing all the features and packages of Matplot library. I'm just importing the PyPlot, which is used for plotting two-dimensional graphs. But I'll rename this PyPlot as PT. Why? Because every time I invoke the feature or attribute of PyPlot, I have to be writing PyPlot dot PyPlot dot. So it will be a huge name. So what I'll do is I'll rename that to just PT. So from Matplot library, I'm importing a package PyPlot, which I have renamed it as PT. That is what I've written in this single piece of code snippet. I just run it. Okay, so successfully it has imported the PyPlot package from the Matplot library, and it has renamed it as PT. And you know that for any two-dimensional graph, there is an x-axis and y-axis, set of points in x-axis and set of points in y-axis. So first we'll define the set of points in x-axis. So we'll have the points 1, 3, and then 5. So 3 points I've put it in x-axis. So if you want, we'll just increase that to 1, 3, 5, 7. And then in y, we'll have a set of points. So that is 2, 4, 6, 8, and then 10. Okay. So we have x and y. Now we have two sets of points which have been taken in the form of a list. So now we'll try to plot a graph using those two lists. So for that, we need to invoke the function plot, which is available in pyplot. So plot x and then y. After plotting the graph, I need to show the graph which is being plotted. So this is the inbuilt functions available in pyplot for plotting the graph and for showing the plotted graph. I'll quickly run this particular code. Okay. So if you see here, it's a linear graph. Why? Because if you can see, for x equal to 1, y is 2. For x is 3, y is 4. So the linearly it is actually changing. The values are changing in a linear fashion. Y is equal to mx plus c. So if I change it, it differs. For example, 4, and here let me make it as 2. So now if I run this, you can see the graph has actually changed. So based on the values of x and y, it plots the graph and it displays the plotted graph. But you know that every graph has a label in x-axis and a label in y-axis, and we can actually give name for a graph. So we'll go for exploring few more features of this particular package. So the same points I've actually invoked. So what I'll do is I'll go for giving a title to my graph. So I'll give pt dot title. So let me give the title as line graph. So let me give the title as line graph 1, and then I'll label the axis also. So x, I'll label it as x axis itself, and then I'll also label the y axis. So these are the inbuilt functions available for labeling your axis. Okay, so successfully we have labeled x axis, we have labeled the y axis, and I've also given the title for my graph. So let me go for running this particular code snippet now. Okay, so now if you see here, my graph is as expected. I have a title for my graph, I have the x-axis, I have the y-axis. And if you can see here, the line is actually used for plotting the graph. So basically it uses a line graph. And I can also go for changing the colors of this particular line. For example, if I want red color and I don't want a straight solid line, I want dashed line. So I can use this. And if I run, okay, you can see here, it has used red color. R stands for red, and then two hyphens actually stand for dashed line notation. So there are different color codings available. I'll put it in the comment section so that you can use it. For red, we use actually R. So I'll write the color codes used. For red, we usually use R, and then for cyan, you use C, and black, we use K. Blue, we use B, and then we have different colors. Magenta, we use M. Green, we use G. So there are different codes available. So few codes I've actually listed which you can explore and use it. And double hyphen actually indicates the dashed notation. So we'll run this code with some other options. So I'll copy paste it here. Same code. Okay. So instead of red, I'll write cyan, and I want dotted lines. I don't want dashed lines. So this stands for dotted lines. So now if I run this particular code, okay, you can see here the color has changed to cyan, and then it is dotted line. So I'll write it. Dashed line. Colon, you can actually use it for dotted line. Dotted line. So these are few actually codes which you can actually use for beautifying your graph. And if you see here, the width of this particular graph is very small. The width of this particular graph is very small. I'll just change the title for graph 2. I'll make, that's it, and I'll run once again. Okay, graph 2. So in the graph 3, we'll try to change the width of that particular line. So I'll copy paste the same code with the value of x also. Okay. Same piece of code we have actually invoked, that is x and y. Only thing is I just want to show the illustration of different other features available in PyPlot. Yes. So the other features which I want to actually show is the width of the line, how I can actually change. So I can make it as line width is equal to 7 points. So I'll keep my line width as 7 points, and then I'll run. And if you want, I can actually change it to colors. I can change it to magenta and then dashed lines. You can see it. The width of the particular line has actually changed. The width of that particular line has actually changed it to 7 points, so that it is a little bit darker now. You can easily view it. Fine. These are different visualization options which are actually available in Python, which could make your graphs beautiful. I can also have two plots in a same graph. For example, I can have pt dot plot. What I'll do is I'll exchange the values of x and y. In place of x, I'll put y, and in place of y, I'll put x. And then I'll use a different color combination. I'll go for green, and then I can go for dotted line, and I can go for line width also. I can go for a little bit smaller line width, that is 3. So let me run this particular code. So you can see here, I can have any number of plots in a particular graph. So these are the options available in Python using the normal regular line graphs, and different color codes for beautifying your graph, for analysis, for showing different results in your projects. If you're using, you can use these kinds of different color codings and patterns. As you have seen in normal graphs where you use different kinds of lines, dotted lines, dashed lines, solid lines, just points, and all those options. So in Python also, we have all these options for beautifying a visualization. So the graphs actually speak out your analysis results of any project. So the beautifying the graph is nothing but making your results appear much attractive to the user who is actually viewing. So these are few options available in normal line graph in Python. So we'll see some other options available in some other kinds of graphs. So I'll copy paste the code so that I have the same x and y on which I can actually illustrate. Okay, and then we have written already three graphs we have drawn. So one was just a blank, another was graph one is graph two, and then we'll change this particular graph's name as graph three. And I'll run once again, just changing the name. That's it. Okay, and then we'll go for some other kinds of graphs. So we'll go for plotting a bar graph now. So we know different kinds of graphs. We have bar graphs, we have line graphs, we have pie charts, we have histograms, we have scatter plots. So we'll see all those options in Python, how I actually do it. So for plotting a bar graph, I have to be writing the inbuilt function name as bar. So it also takes the x and y coordinates. Okay, and then these comment lines I'll remove. I just want a name for my graph. So it is a fourth graph which I'm actually showing you. So I'll just keep the title. So I'll make it as graph 4. So I'll run this. You can see here a bar graph is actually come. So these are the various options that are actually available. So if you want different colors for your each point, so then I can go for color is equal to, so the 5 points, so I can use 5 colors. I'll use magenta, I'll use cyan, I'll use blue. Okay, before that I'll use green, and then I can also use uh, black, that is K. I can go for blue, that is B. So 5 colors I can actually use for my bar graph. You can see here it comes in 5 different colors. So this also I can use. Magenta is nothing but a dark pink, cyan, and then green, black, K, and then blue. So these are different color codes which I've used for my bar graph. So this is my bar graph illustration. So which is a graph 4. And the inbuilt function name which I use is bar. I can actually align it also. For example, I can write align. We have 3 align values for it: mid, left, and right. I can keep it as mid. By default, it is actually mid. I can keep it in left and actually run it. So we'll see if you can clearly analyze the errors, what is actually telling. So he's telling that invalid alignment. Your alignment value is actually invalid, what we have actually used here. So he's telling what are the things which it is actually accepting. So if you can see here, there is a value error. Since it is an inbuilt function, we have to be using the same name and the same way how actually it has been accessed. So he's telling that you have made an invalid alignment. Left alignment cannot be made. So he's telling, see what are the different kinds of align values which are available and which I have actually missed it. So be careful in aligning. So he's telling, so what are the different options available for aligning also. He's telling that bar graph by default it's been aligned in the center. So you cannot change the value of it. So it's creating a value error. And I don't have much control on these functions. Why? Because these functions are inbuilt in the pyplot. These functions are already inbuilt in the pyplot. So I'll keep it as by default. What was the alignment it was showing? I'll keep it as in the same fashion. And I'll run this so that it does not generate any error for me. So this is another kind of graph, bar graph. So we'll go for the next one, that is histogram. So I'll copy the same piece of code, paste it here. And you know that histogram is actually running with one set of values. It's not running with two set of values. It's either 0 or 1. It's usually used in electronic circuits for encoding and decoding. So we usually use histogram for an electronic circuit. So the name of that particular function is hist for histogram. So here also I can use different color combination if I want, or else I can keep it in one color also. So I can change it. I'll cut it so that we'll see it in a basic one color, and I'll name the graph as graph 5 and I'll run. So you can see histogram either 0 or 1. So for how many points I've given it for x, that is 1 3 5 7 9. So you can see 1 3 5 7 and then 9. So I can have for y separately. So what I'll do is I'll write pt dot hist and then y. So here to differentiate, I'll write color is equal to, and then I can go for green. And here to differentiate, I'll write color is equal to cyan. So I can actually do this also. So then I'll get in a same graph, I'll get it in two different colors. So if you can see here, I've got it in two different colors. And then I can also have orientation. For example, I have both now vertical orientation. I can actually change the orientation to horizontal orientation. Spellings have to be same way used here because these are the attributes which are in the pyplot package. These are not the attributes which are given, we are assigning. These are the names which are already available in the package, so we cannot change or do any spelling mistakes here. So orientation will keep horizontal. Okay, so we'll keep the orientation as horizontal. You can see here horizontal orientation, what it has done. So I have taken X as horizontal orientation and Y as a vertical orientation. And you can see here, one doubt which may arise is X is having 5 and Y is having 2. So what it did is, since you can see there are few points which are repeating, 2 and 4, which is already been plotted. So that's why those 2 points are actually eliminated. So this is a histogram. Fine. Okay. So we'll come to the next one. That's the pi. Okay. So we'll go for the next one. That is a pie chart. So I'll have a set of points. So I'll give it as 1, 2, 3, 4, and then 5. And you know that in pie chart, it is actually labeled. It's a circle, which is 100%. And the ratio of these are actually represented in this circle. Highest ratio is given for 5. Then 4. So it divides. So total it counts like 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 14, plus 1 is 15. So what it does, 100% has to be divided by 15. So that is the value of 1 point. So based on that value, it gives the percentage to each of these points. And then we can actually label it. So the label values, I'll keep it in Y. So what I label is, I'll label it as A, and then I'll label it as B. I'll label it as A, B, C, D, and E, so that these label points actually appear corresponding to that particular values of X. Okay. And then PT dot pi X and the label value. So I'll give labels equal to Y. Okay. Finally, I'll show the graph. So PT dot show. I'll run this. Let me have a name for my graph. So PT dot title, let me have it as graph 6. So let me change the title as graph 6. Okay. And then don't get confused, the above graphs were not line graphs, it's an histogram. So I'll just change the names which we have used here. Okay, so histogram, so that the same name comes on the graph. And this is a bar graph. I'm very particular about these namings also, so excuse me with this couple of minutes for changing the names of it so that the output is clean and beautiful. Okay, so we'll come to the topic, that is a pie chart. So I've named it as a pie graph. Pie graph, that's the sixth graph which we're actually plotting, and I'm using X for graphing that, and then Y is just a label. So we'll run this. So you can see here, my pie graph is actually ready. So the highest portion is for E. So you can see the highest ratio is actually for E. So various options are available. In some cases, you know that I want to highlight A. I want to bring the A outside. That is like cutting a pizza. So how can I do that? So what I'll do is, I'll use the separator concept. So I'll use separator. So I have to give separator values for all the 5 points. So how many, by how many points I want to separate? I just want to separate A by 0.1. So I'll give 0 for others. Okay. So there are 5 points. All are separated by 0. Only A is separated by a distance of 0.1. And then I'll write explode is equal to separator. Okay, now see the difference what I usually get here. Okay, there is some small mistake which we have done. So we'll quickly see what is a mistake. Okay, the name mistake. It is SPT. I have written SEP. Yes. Change the error. Okay. So if you can see here, my A has been cut and it has been sliced outside. So since if it's not visible to you, what I can do is I can slice it with a higher point. See, my A has been removed and shown outside. So these are the ways of beautifying your solutions and answers. If I have to highlight certain portion of my graph, how can I bring it outside? So now clearly whoever is viewing this graph, he can actually come to see that, okay, A is what I want to highlight. A is what I want to show, bring him outside. So if you want to show A and D, then you can make, where is D? Here. So D also you can bring it by 3 points outside. See, so this is how you can actually do it. So these are the different ways how you can actually beautify or visualize your graphs or concepts in Python. And since the course is on data visualization using Python, so these concepts are very, very important when you're going for your final year projects or SPSS projects where you want to show your analysis part. And these concepts, if you're using Python programming languages, it's very easy to illustrate in your code itself. You can have in your code itself implementing the matplot library to plot graphs based on your results. Okay. So we have seen pie chart also. The last one, my personal favorite, that's the scatter plot. So we'll see the scatter plot. How is it? So 1, 2, 3, 4, and then 5 points I have written. And then y also, I'll have a few points. I'll write 1, 3, 4, 2, and then 7. So 5 points in x and 5 points in y I have. And then pt dot scatter. It's a scatter plot. X and then y are the 2 points which I'm using for scattering. And then the title will keep it as scatter, and the graph is 7. So scatter graph 7 will give, okay, scatter graph 7 is the name, and then pt dot show. Okay, so this is what is a scatter graph. It took x and y values. Fine, the name of the graph is this. What I mean by scatter is, you would have seen in some data science and machine learning projects where the points are in the form of dots. So that is what is scatter plotting. Okay, so see, the answers are in dots. And still more beautifying this, what I can actually do is I can give colors for them. So I can give the colors. There are 5 dots, so 5 different colors I can use. For example, first one is I can go for green. Second one I'll go for blue, and then next one I'll go for yellow, and then I'll go for red, and then I'll go for cyan. So 5 colors are over. Yes. So what I've done here is I've told, don't use the same color, use 5 different colors for 5 different points. So you can see here, there are 5 different colors used for 5 different points. So this is a scatter plot. Fine. Okay. So where you see the scatter plot is usually in clustering, classification, in data regressions, linear regression projects and all. If you see certain graphs are plotted where you see cluster of points. For example, let me show you a simple code snippet where I can illustrate large number of points being plotted. So since I cannot give manually 150 points, so what I'll do is I'll use a list comprehension for I in range. We'll go for range 150. So 150 points are there. Okay. And then I'll have a function for defining the points of y. So what I'll use is I'll use a function. Okay. In this function, I'll give random values to y. So since I'm using random values to y, I'll import a package called random. Very easy package, which is used for generating random numbers. So one small function of the random package will actually implement in this piece of code. So function, I'll create an empty list. Okay. And then 150 random points I have to generate. So I'll give for range 150 lt dot append. So random integers will generate between few ranges. So I'll invoke the random module dot rand int. So this is an inbuilt function available which generates an integer number between the two ranges which I'm passing. So I'm passing two ranges, A and B. So in this range, it generates random number and appends it to the list LT. And finally, I'll return that list. I'll return LT. So what I'll do is my Y is now the result of that particular function. Okay, so you can see here, my X is a list comprehension which generates 150 points, 0 to 149. And my Y is a list where I don't know what are the values because it's a random number generated each time. And how many random numbers are generated? 150 random numbers are generated. So now I got X and Y. So now I'll try to plot the scatter plot. Okay, so scatter, I have X, I have Y, and I'll make my color is equal to cyan. I'll give the color as cyan, and then you can see different colors are used, but 150 colors, instead of giving that, I'll give all the colors in cyan. And then pt dot title I'll give as I think it's the 8th graph which you are drawing. So graph 8. Yes, it's 8th graph which we are drawing. So I give the name as graph 8. So I'll just show the graph. Yes, so it's clear now. So pt.title and show scatter. So X and Y. So this is a small piece of code which I've written for generating 150 random numbers for Y in the range 5 to 25. I'll run this. So you can see here, it has generated a scatter plot. So X, if you see, it is from 0 to 149. So X, if you see, it is 0 to 149. And Y, if you see, it is from a random number between 5 to 25. So you can see here, the numbers are between 5 to 25 only. So these kinds of graphs, you can see it in clustering and all. So what do you mean by clustering is what are the points which are very near to. So if you can see, the circles here are very near. So that means they have same features. So these are some concepts of your data science and data analysis. And usually we use scatter plots for showing our visualized results in these high level projects. So you can use anything in your final year projects or in your SPSS projects to plot the graphs and visualize your results so that it looks beautiful. And the one who's seeing this particular graph feels attractive to look into it and then finds interesting. Fine. Okay. So these are the kinds of two-dimensional graphs. Much enough of basics I've actually shown in this particular tutorial. So let me show you another kind of graph, that is a 3D graph. So 3D graph is not implemented in Matplot library. Matplot library is usually used for two-dimensional graphs. But if you want 3D graphs, I'll show you a package from where you can actually get 3D graphs. So you get MPL toolkits, mplot 3D. Okay. So there is a package called MPL toolkits from where I'm actually importing a package called mplot 3D. So we'll see whether this package is there. Yes, successfully that package is actually imported. Okay. So now we'll try to plot a 3D graph. So I'll give X value, that is 1, 2, 3, 4, and then 5. And then we'll have Y value, that is 2, 1, and then 4, 7, and then 3, and then 6. Okay. So Y also have. So we'll go for plotting a 3-dimensional graph. So I have to mention the axis. Number of axes is not 2. Number of axes is 3. So I'll use X equal to pt dot axis projection is equal to 3D. Since I'm doing a 3D projection, I have to give this, saying that I'm not using 2 axes, I'm using 3D projection axis. Clear? And then I'm writing it here. See, PT is actually a pyplot package, and I'm just using a variable AX. And now AX is having 3 axes. So using that, I'm actually plotting. So AX dot plot X, comma, Y, and we'll use 5 different colors also so that it looks beautiful. We use cyan, and we'll use green, we'll use yellow, and then we'll use magenta, and then we'll use red. Okay, so 5 different colors also I've used. And then I'll show the graph. So pt dot show. So if you look carefully into this code, what I've done is I've said that number of axes is not two, it's a 3D axis. And then I'm plotting it using X, Y. But if you want 3D, it is X, Y, and Z. So what I'll keep it to Z. Fine. X, Y, and Z. We'll copy paste the same values to avoid our time. Okay. Yes. So we have X, Y, and then the third axis, that is Z. We'll run this piece of code. Hopefully we'll get a 3D graph, a beautiful graph. Some small mistake we have done. So we'll see what's the mistake which we have actually done here. Unhashable type called, okay. So I've written x dot plot xyz. So we'll see what's the error which is actually been thrown here. And we'll try to remove that particular error in case of 3D graph. So look carefully into the things what he's actually saying. Fine. So he's telling that you are having a invalid RGBA argument configuration here. You are having a value error which you have actually generated here. So what we'll do is we'll try to cover that. So look carefully into the error what has been shown so that you can easily identify and rectify it. He's telling that there is a small mistake on how you have actually invoked your list. Fine. Okay. So we'll remove this and we'll see whether this 3D graph is actually plotted for us. Yes, so if you can see here, there is a 3D graph which was being plotted and the error was in the color combination which I actually gave. The error was in the color combination which I actually gave because I tried to give the scatter configuration. Now it is a line graph which is actually being plotted. Fine. Okay, so we'll name this graph also. We'll name this graph as pt dot title 3D. So it's a 3D graph. So we'll give it as 3D GRA line graph. So it is a 3D line graph number 9. Okay. So we'll see how I can go for a scatter plot in 3D. Fine. So this was the line graph. So we'll go for scatter plot. So what I'll do is I'll change it to scatter. I'm usually fond of these scatter graph. So I want to end up in scatter graph. So I'm giving scatter graph option here also. Okay. Now we'll try to use that option of color, which was thrown error. So cyan, and then I'll go for green. 5 colors I have to use for 5 different points. After green, I'll go for red, and then I'll go for yellow also. And then I'll go for yellow, green, magenta color also I can go. Okay. So there are 5 colors being used, and it's a scatter plot, and it's not a line graph. So we'll run and we'll see. Yes, so you can see here there is a 3D graph where we have scatter points available. So these are the concepts of Python graphs, how you can actually implement graphs in Python. Usually we don't go for 3D graphs unless until there are 3 parameters to be simultaneously analyzed in your projects. We usually go for 2D graphs itself. So matplot library is quite enough to illustrate 2D graphs. But still, if you want 3D graphs, you can actually import this particular package, which is very interesting in plotting 3D graphs. So you can plot graphs for your projects. Very, very important when you come to your final years, where you actually have to show your analysis part, the result part in your projects have to be showed using graphs pictorially. You have to visualize it. And the more beautified visualization, it clearly illustrates your results. The attractiveness of your project actually increases in these interactive as well as visualized graphs if you could plot it in your projects. So this is a concept of graphs in Python. I hope I have given you much basics on Matplot library and in 3D plotting in Python. Any queries if you have, you can get back to me through my email ID, which I'll be sharing it here. So you can contact me on my email. I'll just share it here so that any queries if you have, you can mail to me. Okay. So this is my mail ID where you can actually contact me if you have any queries regarding to this particular topic, and I would be happy to brief you on that particular query. Okay. So this is my email. You can get back to me in case of any queries, and feel free to share your knowledge on graphs also. I'd be happy to take that knowledge also if you have any extra knowledge on graphs which I could adopt in my next learning sessions for my students. Thank you, and then see you in the next session.